Hello everybody, so today let's go into chapter 3. So chapter 3 is on electric current and direct current circuit. So this is quite a long chapter. There are 9 subtopics if I'm not mistaken. So let's get into this chapter. So the first one is on electrical current. So in this subtopic, you have to be able to describe the microscopic model of current, emphasizing on the flow of free electrons in a metal, and we should include the concept of drift velocity. Next, you have to define electric current, and lastly, use the electric current punya formula lah. Okay, so electrical conduction, let's go into the microscopic model of current. So we know that metal is a good electric conductor and it has free electrons that act as a charge carriers, okay? So this electron is carrying charge across the metal lah. So if there is no electric field inside the conductor, the free electrons will move randomly in all directions, such as shown here lah. If an electric field is present, the electric force, we know the formula is this one. It causes the free electrons to move slowly along the conductor in a direction that is opposite of the electric field at drift velocity. So basically it is moving this way at drift velocity lah, okay? So it is moving opposite of this electric field. So why? Because electron is a negative charge, so it would be attracted to the positive charge of the electric field punya area lah, okay? So electric current is the symbol is I, and it is defined as the rate of flow of charge, and the formula is given here. So this is the amount of charge that passes through the conductor at any location during the time interval, and this is another formula for you to calculate the amount of charge, which is n, where n is the number of charge times the bukan the number of charge, berapa banyak darab dengan the amount, the charge punya value. Ialah di berapa satu 1.6 times 10 to the power of negative 19 if I'm not mistaken. And then we have dt, which is the time interval, and then it is a scalar quantity with the SI unit of ampere lah. Lepas tu usually they would ask you what is the definition of 1 ampere. So 1 ampere is defined as 1 coulomb of charge passing through the surface area in 1 second, okay? So as we all know, electric current can be measured using an ammeter, so it is always connected in series lah, okay? What else should we... Okay, so the flow of current will always be present. Current will always be present as long as there is a difference in the potential difference lah, okay? So kalau ada potential difference, kita ada the flow of current. So let's look at this. This is a battery, so it is connected to a light bulb. So the light will only light up when there is a difference in the potential. So contohnya di sini sekarang ni dia ada high potential, so it will flow across here, causing the flow of current lah, okay? So basically there is a presence of current. So sekarang ni bila ada current, barulah dia boleh light up. So why is it happening? Because there is a difference in the potential between these 2 points lah, okay? So a difference in potential, as we all know, will also cause a fluid to flow, okay? So sekarang ni kita tengok, kalau this pipe is at the same position at both points here, they will be at the same potential. So contohnya sekarang ni kita tahu MGH, so potential di sini, so ini adalah kita punya reference point. But when they are at different potential, so sekarang ni this is our the reference. So this is our H equal to 0, so H equal to something here. So there's a difference in the height of the pipe. So when there's a difference in the potential punya value. So dia ada delta U lah, the change in potential energy. So because of the change in potential, it causes the fluid to flow. Okay, so sama juga macam current. So kalau ada difference in potential, barulah ada current flow. Okay. The direction of current is always opposite to the direction of flow of electrons. So electrons will flow from the negative terminal to the positive terminal, whereas current will be going from positive to the negative terminal. Okay. Okay. Yeah. So basically, this is for subtopic number 1. Let's look at example number 1. So there is a current of 0.5 ampere in a flashlight bulb for 2 minutes. How much charge passes through the bulb during this time? So sekarang ni kita kena bagi current which is 0.5 ampere and then the time is 2 minutes. Okay? So we know that to calculate the amount of charge passing through the bulb, we can use the equation of Q and E. But we also have an equation that we can use which is QIT. Okay, dari mana kita dapat Q equal to IT? It's basically this one here lah. So this is IQ over T, which is basically Q equal to IT. Okay, so that is also an equation for the amount of charge. So bolehlah kita substitute dua-dua ni here. So we can then the amount of charge per how much charge passes through the bulb during this time. So this is N over T lah. Astaga, apa sebab ni? That is question 2. Sorry everybody. That is basically QIT. Astaga. This is 0.5. This is 2 times 60 because we are using seconds. So this will be 60 coulomb. Question 2 pula, a silver wire carries a current of 3 ampere. So we have to determine the number of electrons per second passes through the wire. So that is what I've talked about di atas. So this is the equation. So when we equate these two equations together, we will get N over T, which is the amount of electrons per minute. Ataupun dia minta per second. So over time lah, number of electrons over the time. So kita dapat I over E. So this is 1.6 times 10 negative 19 over the current is over the charge of electron. Oh my god, I am sorry if this is a bit of a mess because I've just got back from the holiday and my brain is not working. Okay, so that is the unit lah. The answer is this one here. So basically, sometimes the question would ask you to use 2 equations to solve one question. Okay, macam tu lah. So example number 2 pula, we have figure showing a conducting wire. The cross-sectional area are located 50 centimeter apart. Every 2 seconds, 10 coulomb of charge flow through each of these areas. So we have to determine the current in this wire. Okay, so the time is 2 seconds and then 10 coulomb of charge. So there's 10 coulomb of charge passing through the wire every time, and then we have to determine the current in this wire. Again, that is just basically QIT. So I is just Q over T. So this is 10 over 2, which will give you 5 ampere. Okay, so that is example 1 and example 2, and that is basically for subtopic number 1.